All right, you are welcome again. Let's take a look at this question under some special cases in logarithm. Find the value of x. We have 10 times 2 raised to the power x is equal to 8 times 5 raised to the power x plus 1. We have 10 times 2 raised to the power x is equal to 8 times 5 raised to the power x plus 1. What would be the value of x here? So that is what we are asked to find, okay? Now let's go. As it is, let's take the logarithm on both sides. If we take the logarithm on both sides, that means we're going to say log 10 times 2 raised to the power x in brackets equal to log 8 times 5 raised to the power x plus 1, all in brackets. Okay? Yes. From here, when we say log 10 times 2 raised to the power x in bracket, this is times, right? We can change it to addition, but it's going to have log, right? Good. That means we're going to have log 10 plus log 2 raised to the power x. It's still the same thing. Because when you want to say log 10 plus log 2 raised to the power x, since they have the same base, you can say 10. You're going to say log 10 times 2 raised to the power x, the same as we have above, right? Good. Equal to, in the right hand side, we split it also. We have log 8 plus log 5 raised to the power x plus 1. Is that true? Yes. Okay, from here, the exponent, let's take them to the back. We have log 10 plus this log 2 raised to the power x, this x power, we take it down to the back. That means we're going to have x log 2, okay, equal to log 8 plus this x plus 1 in the power of 5. We take it down to the back. That means we're going to have x plus 1 in bracket log 5. Okay, good. Now, here we have log 10 plus x log 2 equal to log 8 plus. Here we have x plus 1 log 5. Let's use this log 5 to open the bracket. That means we're going to have log 5 times x. It's going to give us x log 5. And log 5 times 1 is going to give us log 5. So after this operation, we have log 10 plus x log 2 equal to log 8 plus x log 5 plus log 5. Okay, good. Now let's bring the terms that are the same, or let's collect the like terms. The ones that are having x, let's bring them together. So in the left hand side, we already have x log 2. Let's hold it. And in our right hand side, we have x log 5. Let's bring it to the left hand side. That means we're going to have minus x log 5. Okay, equal to, we have log 8 plus log 5. Then log 10 in the left hand side, let's take it to the right. We have minus log 10. Is that true? Yes. So let's factor out x in this logarithm here in the left hand side. That means we are going to have x open bracket log 2 minus log 5 equal to, in the right hand side where we have log 8 plus log 5 minus log 10. Since they have the same base, we can pick one of the log and say it is the same as 8 times 5 all over 10. This log 8 plus log 5 is the same as log 8 times 5. And then this minus 10 will give you all over or divided by 10. All right, good. That means we have log 8 plus log 5 minus log 10 is the same as saying log 8 times 5 divided by 10. Okay, so when you say 8 times 5 is 40. 40 divided by 10 is what? 4. So that means we have log 4. So log 8 plus log 5 minus log 10 have reduced to log 4. Is that true? Yes. Now let's go. Here we have x open bracket log 2 minus log 5 close bracket is equal to log 4. We are looking for x. Let's divide both sides by log 2 minus log 5. So we have x, open bracket, log 2 minus log 5 all over log 2 minus log 5 equal to log 4 all over log 2 minus log 5. So in the left hand side, log 2 minus log 5 we cancel log 2 minus log 5. Okay? Equal to, in the right hand side, when we say log 4 all over log 2 minus log 5, what will it give us? It's going to give us approximately minus 1.5129. So here, after evaluating, we see that x is approximately minus 1.5129. Please try and fix it in the expression. Let's see whether we are correct. Okay, yes, we are correct. All right, thank you very much for watching. Let's take more examples. Stay blessed.